Hello everyone, welcome back to Excel Education Center. I'm your math teacher, Fairul Rahman. Sorry. I'm your math teacher, Fairul Rahman. FR here, you can call me FR. And today we are going to discuss the chapter Matrices and Determinants. After that, your teacher Fairuza will be here to teach you the chapter Probability. And shall we move to the first question? Okay, it's an easy chapter, guys. It's very easy chapter, and you can get easy marks also. Then the first question is, if A is a matrix of order 3 by 2, if A is the matrix A is a matrix of order 3 by 2, then the order of the matrix A dash, or we can say A transpose, order of the matrix A transpose. A dash means A transpose. So first of all, you have to know what we mean by A transpose. Okay, wait a minute. Look at the charts. Okay, here, what we mean by A transpose? If there is a matrix A, that contains the elements 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A transpose will be, we will interchange the rows and columns. We will interchange this row into column. 1, 2, 3 will be here. This row will become a column, and 4, 5, 6 will be like this, and 7, 8, 9 will be like this. Okay, this is the transpose. Okay, so here the order is 3 by 3. Here also the order is 3 by 3. What we mean by an order? Order is this first one is representing the rows and the second one represents the columns. Ready? Okay, here the rows and columns are equal, therefore the rows and columns of this transpose is also equal. But when you write another matrix B, that is 1, 5, 6, 8, 9, 10. If you find the transpose of this matrix, what will happen? Listen, this column, this row become the first column, and the second row become the second column. You can see this is a 2 by 3 matrix. That means it has two rows and 3 columns. For this one, it is 3 rows and 2 columns. So what happens here? If you take the transpose of a matrix, the order will also interchange. The number of rows and number of columns will also interchange. So if this matrix having order 3 by 2, then the transpose will have the order 2 by 3. 2 by 3. The answer is 2 by 3. Did you get the answer? All good? Okay, then we can go for the next question. Okay, ready? We can go for the next question. That is, listen. A square matrix A is said to be skew symmetric if there is 2 types of matrices that is related to transpose, that is symmetric and skew symmetric. I'll give you a look in that. If a matrix A is equal to 1, 2, 3, 5, 6, 7. If a matrix is like this, and wait. You give 1, 2, 3, 5, 6, 4, 2, 3, 4. Okay. If you take the transpose of this matrix, what you will get? The transpose will be like this. This row become column, right? And this row become the second column, right? And this row become the third column, right? So look at here. This matrix and the transpose of that matrix are equal. That matrix, the transpose is equal to that matrix itself. Then we say this matrix is a symmetric matrix. Okay? Then what about skew symmetric? I'll give you an example. If a matrix B is equal to, here, all the skew symmetric matrix will have the diagonal elements as 0. then here 1, 2, 3 and negative of that number. If you take the transpose of this matrix, what you will get? B transpose will be equal to what? 0, 1, 2 and minus 1, 0, 3, minus 2, minus 3, 0. Listen guys, listen carefully, listen carefully. Here you can see these positive numbers changed to negative numbers and these negative numbers changed to positive numbers. That means B transpose is negative of B. B transpose is negative of this. Ready? Negative of that matrix B. Then we can say B is skew symmetric. B is skew symmetric. Did you get it? Then what was the question? A square matrix is said to be skew symmetric if A transpose is equal to negative A. If this matrix A should be, A transpose should be negative of that matrix. Okay? Did you get it, guys? Did you get it? Okay? That's all. It's a simple question. Listen, if it is a symmetric matrix, A transpose will be equal to A. If it is a skew symmetric matrix, A transpose will be equal to negative A. That's all. That's all the concept. That's all the concept. Ready? Shall we move to the next one? Okay. The next one. If the matrix is a skew symmetric matrix, then the value of K. For if a matrix A, the matrix A, what is a matrix A? 0, 3, 5, K plus 1, 0, 4, minus 5, K, 0. And the transpose of this matrix will be what? 0, 3, 5, K plus 1, 0, 4, minus 5, K, 0. Then they said A transpose is equal to negative A. That's what they mean by skew symmetric. That implies what? What is A transpose? What is A transpose? This is our A transpose, which is equal to negative A. What is negative A? Negative of this matrix. That is 0, minus 3, minus 5 and minus of K plus 1, 0, minus 4, plus 5, minus K, 0. From here, you can find that 4 is equal to minus K, because if two matrices are equal, then the corresponding elements will be equal. That means 4 is equal to minus K, K is equal to minus 4. That's all. Okay, this is the application of what? This is the application of symmetric and skew symmetric matrices. Okay, ready? All good? Is there any doubts? Is there any confusions with these questions? These are the simplest questions. Symmetric, skew symmetric and all others. Ready? Shall we move to the next one? Ready? The next one. If A is equal to, they have given you a matrix and A is equal to N transpose. That means it's a symmetric matrix. It's a symmetric matrix where A transpose is a transpose of the matrix A. We don't want that actually, because we know what is A transpose is. And then we want to find a relation that relates the X and Y here. So here, look at it. Here A is equal to 5x y0. Then A transpose is equal to 5x at the column, y0 is also on the column. Then these are equal. That means 5x y0 is equal to 5y x0. Because A and N transpose are equal, they are symmetric. So what we say? Here you can see 5 should be equal to 5. If two matrices are equal, then the corresponding elements should be equal. Here you can see x should be equal to what? Y. X equal to y. So the relation is x equal to y. The relation between x and y is they are equal. Okay, then the x and y is equal. The option B is the correct one. All good? Is there any confusion in it? It's a simple question, because A transpose is equal to A, then we have to find the relation between x and y. Here the relation between x and y is x equal to y. Okay, then the logic is if two matrices are equal, then the corresponding element should be equal. This should be equal to this first element. The second element in the first row should be equal to the second element in the first row of the second matrix also. Okay, shall we move to the next one? Is there any confusion with this question? Okay, so the next one is they given you a 3 by 3 matrix. The order of the matrix is 3 by 3. that is there is 3 rows and 3 columns, then the order of the matrix is 3 by 3 matrix. Then you want to find A into adjoint A. So first of all we need to find adjoint A. To find adjoint A, you have to find minor of A, then you have to find cofactor of A, then you want to find adjoint of A. So in this question we are going to discuss the topics, that is minor, cofactor and adjoint, and multiplication of two matrices. Addition and subtraction of matrices is very easy, but multiplication is little bit complicated because we want to multiply the row with the column, so that kind of cross multiplication is there. So we have to find the adjoint A first. To find that we need to find minor A. How we will find the minor of A? How we will find the minor of A? Listen carefully, listen carefully. Here you can see, if you want to find the minor of the first element, you have to eliminate the row and column of the first element. Then you have to cross these two terms. 2 into 5, that is 10. 2 into 5 is 10, and that is 10. Then you have to subtract the product of these two elements, that is 9. 10 minus 9, that is 1. So the minor of the first element is 1. How did you get that? You have to multiply these two elements first. After eliminating the row and column, you have to multiply these two elements, that is 10. Then you have to subtract the product of the other two elements from it, that is 10 minus 9, you will get 1. I'll find all other minors. That is, if you want to find the minor of 0, you have to eliminate this column and this row. Then minus 1 into 5, minus 5, minus 5, minus 3 into 3, that is minus 9, you will get minus 14. What about this one? Cancels off, you will get minus 3, minus 6, minus 9. Ready? What about the next one? Minus 3, minus 6. Then what about this one? You have to eliminate this and this. What you will get? 0. It is 0. I think you can find others, right? What about this? Eliminate these two. You will get 10 minus 0, that is 10. What about this one? You will get 6 minus 0, that is 6. You have to eliminate this, that is 0. You have to eliminate this one, you will get 6 minus 0, that is 6. And you have to eliminate this, you have 4. So this is minor. Then you want to find cofactor. You can do it with me, right? Don't going to finish. Okay. After that, you want to find cofactor. There is an easy way to find cofactor. If you have a 3 by 3 matrix, you should write this. You should remember this pattern: plus minus plus minus plus minus plus minus plus. So you have to multiply the corresponding terms with the sign. Plus into 1, positive into 1, that is 1. Negative into negative become positive. Positive into negative become negative. Negative into 0, 0. Positive into positive become positive. Negative into positive become negative. Positive into 0, 0. Negative into 6, negative 6. Positive into positive 4. That's all. That's your cofactor. Then after that you have to find adjoint A, that is the transpose of cofactor. You want to find the transpose of this one, you will get the cofactor. That is 1. You want to find the transpose of cofactor to get adjoint, that is 1, 14, minus 9, 0, 10, minus 6, 0, minus 6, 4. This is your adjoint. After that, you want to multiply this adjoint with A. I'm going to do that. Listen. Now we want A into adjoint A, and we have A. What is A? A is 2, 0, 0, minus 1, 2, 3, 3, 3, 5 into what? Adjoint A. What is adjoint A? What's our adjoint A? this should be minus 6 and 4. Okay, adjoint A is 1 0 0 14 0 minus 6 minus 9 minus 6 and 4. How will you multiply this? How will you? To multiply, matrix multiplication is little bit different, like row into column, row into column. Matrix multiplication is like that. You want to multiply the row into column, don't multiply the corresponding terms. Okay, 2 into 1 become 2, and 0 into 14 becomes 0, 0 into 9 becomes 0, and all these two terms become 0, and 2 into 1 become 2. That's all. And the next one, 2 into 0 0 0, 0 into 0 0, 0 into minus 6 is 0, and the all term becomes 0. Here 2 into 0 becomes 0, and if you multiply these two terms with these zeros, you will also get 0. Corresponding terms, multiplying the corresponding, I will show you. Multiply this with this, multiply this with this, multiply this with this. That's all, and add all that together. Okay, I'm going to erase that, and after that you should multiply this with this, and this with this, and this with this, and add the result of the product. Okay, like that, like that, like that. Minus 1 into 1 become 1, minus 1 plus 28 and minus 27. Ready? Then after that, listen, multiply this row with that, these two terms become 0, and the third term will be minus 18, right? Minus 18. Ready? Then 0 minus 12 plus 12, minus 12 plus 12, then 3 plus 42, 3 plus 42 minus 45, then 0 minus 30, then 0 minus 18 plus 20. So these are the results, and the final answer will be like 2 0 0 and 0 and minus 18 0 and 45 42 minus 3 plus 3 0 minus 30 and 2. So this will be your adjoint into A. You should calculate it correctly because I'm doing it really fast. You want to recheck it. Okay, then shall we move to the next one? So always listen, when you multiply two matrices, it is not multiplication of the corresponding terms, it is multiplication that is row into column, row into column. Okay, so row, the corresponding terms will be multiplied with the row and column and added together. That's how we will do the multiplication. Okay, shall we move to the next one? Okay, the next one is, if for a square matrix A square minus A plus I is equal to 0, then they want to find A inverse equals to what? They want to find A inverse equals to what? Listen carefully. If A into A inverse, the product of A into A inverse is equal to I, and A inverse will be cancelled and you will get identity matrix. So listen carefully. I'm going to write this equation A square minus A plus I, which is equal to 0, right? I'm going to write it like A into A minus A plus I is equal to 0, and I'm going to multiply both sides with A inverse. What happens then? Listen carefully. This A into A inverse become what? A into A inverse is I. So I into A minus A into A inverse become what? That is also I, plus I into A inverse become what? That is A inverse, and 0 into A inverse become what? That is 0. So after that, here A inverse will be here, and this A into I, anything with, if B into I, that is also B. If I into A inverse, that is also become A inverse. So if you multiply matrix with I, that is identity matrix, you will get the matrix itself. So then this negative I goes to the right side, you will get positive I, and this positive AI, A into I, that is A, go to the right side, you will get negative A. So the answer is A inverse equal to I minus A, the option C. So I think you get it right. Okay, so can I go to the next question? Ready? Listen guys, listen carefully. Express the following matrix as a sum of symmetric and skew symmetric matrix. You can expect this question in your board. Okay, listen carefully. I'm going to represent a matrix P as symmetric matrix and a matrix Q as skew symmetric matrix. I want to find two matrices, one is symmetric, another one is skew symmetric, and if I add that together, we have to get what? This matrix, the question. So how will you find that? I'm going to add the transpose of the given matrix with it. I'm going to add the transpose with the given matrix. What you will get? The given matrix is 3, 5, 1, minus 1 plus the transpose of the given matrix, that is 3, 5 in a column and 1 minus 1 in the next column. If you add these together, what you will get? 3 plus 3 becomes 6, 5 plus 1 becomes 6, 5 plus 1 becomes 6, and minus 1 become minus 2. So this is A plus A transpose. Listen here. If you find the transpose of this matrix, you will get this matrix itself. Like you can see, what is the transpose of this matrix? This 6 and this come to the column, and this 6 and minus 2 come to the next column. What you will get? The same matrix. So it's a symmetric matrix then. It's a symmetric matrix, and I'm going to find the half of that matrix. I'm going to find the half of that matrix. What happens then? I want to find all the half of all these elements. That is 3, that is 3, that is 3, that is minus 2. Sorry, that is minus 1. So this is also a skew symmetric matrix. So I call this matrix P because it's a symmetric matrix. P is our symmetric matrix. Then I want to find a skew symmetric matrix. It's very easy. If you want a skew symmetric matrix, you want to subtract the transpose from the given matrix. So what you will get? A will be 3, 5, 1, minus 1 minus a transpose will be 3, 1, 5, minus 1. If you subtract the corresponding terms, what you will get? 3 minus 3, 0. 5 minus 1, 4. 1 minus 5, minus 4. Minus 1, minus 1. Minus 1, minus 1. This minus and this minus become positive, and that will cancels off. I said before, the diagonal elements of a skew symmetric matrix will be 0. So here you can find the diagonal elements are 0. And if you take the transpose of this matrix, this 4 become negative and this 4 become positive. Then it is skew symmetric. The negative of the given matrix will be, when you find the transpose, if you get the negative of the given matrix, then it is the skew symmetric matrix. So I'm going to find the half of this matrix, that is a transpose by 2. What you will get? 0, 2, minus 2, 0. This is also a skew symmetric matrix, and I'm going to call it as Q. Now we have two matrices. One is P, another one is Q. If we add these together, what happens? I'm going to add these two matrices. First one is P. P is 3, 3, 3, minus 1. And second one is Q. 0, 2, minus 2, 0. If we add these two matrices together, what you will get? 3 plus 0, that is 3. 3 plus 2, that is 5. 3 plus minus 2, that is 1. Minus 1 plus 0, that is minus 1. What is this? This is the question. 3, 5, 1, minus 1. This is the question. So what we get? This is a symmetric matrix. This is a skew symmetric matrix. If we add these together, you will getting the question. So what was the question? Sum of symmetric and skew symmetric matrix. Express the following matrix as the sum of symmetric and skew symmetric matrix. Now we get the answer right. So shall we move to the next question? It is easy one. Is there any doubts, guys? Any confusion with this question? Tell me if you have anything. Otherwise, give me some thumbs ups. Okay? Okay, then shall we move to the next question? I'm going to the next question. Okay, listen guys, if A is a square matrix, matrix A is a square matrix of order 3, the matrix is having the order 3 and the determinant of the matrix A is equal to 5, then the value of 2 determinant 2 A transpose, 2 times A transpose. Listen, here I am going to teach you something, that is, if there is a determinant 2, 4, 8, 2, 10, 4, 8, 2, minus 2. It is a determinant, and if you want to take a number 2 from this, if you want to take out a number 2 from this determinant, you are not only allowed to take a 2 from a single row or single column, not from all the elements. If you take a 2 outside, you're not only allowed to take 2 from a single row or single column, any of the row, any of the column, but only single one, that is 1, 2, 4, 2, 10, 4, 8, 2, minus 2. While you're taking these 2 outside, these 2 row is affected 0. No, nothing is happened to these 2 rows because I only take 2 from this first row. That is the rule. If you want to take another 2, what happens? I can take it from the second row. Also, I can take it from the third row. If I want to take 2 2's from the determinants, then what you will get? This will become 1. This will become 1 and 5 and 2 and 4 and 1 and minus 1. Then it will be like 2 raised to 3. This 2 into 2 into 2 become what? 2 raised to 3, right? 2 raised to 3. If you take 2 from each rows, then there will be a 2 raised to 3 because there is 3 rows. If there is 4 rows or 4 columns, then there will be 2 raised to 4 if you are taking 2. Otherwise, I'm going to tell you something, that is, if a 3 by 3 matrix is multiplied with k, then you will get like this: k, 2k, 3k, 5k, 8k, whatever the constant. Here the constant is 2. Now I'm talking about a general constant, that is k. Then 10k, 11k, 18k, 3k, 1k. When you want to take a k, there is 3 rows. You want to take all the k, you should take k raised to 3. 1k from this row, 1k from this row, 1k from this row. If it is a 4 by 4 matrix, you have to take 4 k's. If it is a 5 by 5 matrix or order 5 matrix, you have to take 5 k's. Then what will be our answer? Then what will be our answer? Listen. We want to find determinant of 2 times A transpose. If you multiply a matrix with 2, a scalar, all the elements will be multiplied. But if you take that from, if you take a 2 or a constant outside from a determinant, you have to take it from every row, each one. Then what happens here? Here you can say it is a 3 by 3 matrix, therefore there will be 3 rows or 3 columns. You can take 2 raised to 3 outside, you can take 2 raised to 3 outside, then there will be determinant of A transpose. And you want to know one more result, that is determinant of A transpose is equal to determinant of A. The transpose will not affect the value of determinant. Determinant of A transpose is equal to determinant of A. The transpose is not affecting the determinant. Okay, then what is the value of 2 raised to 3 is 8, and determinant of A transpose is determinant of A, and what is the value of determinant of A? Determinant of A is 5. Then the answer is 40. What is the correct answer? Option D. I think you get it, guys. All good? Okay, shall we move to the next one? Okay. Then here, actually this question is from the topic properties of the determinants, that is deleted, but without property you can find the answer of this problem. So they may ask you this question. That's why I'm taking this question right now. You can find the determinant of this, right? whether it is there is a variable or constant. You can find the determinant with respect to the first row. What you will get? Alpha into, and you eliminate the column and row of that particular element, and you will multiply 2 into 2 become what? 2, minus 4 into 1 become what? 4, minus second element, that is 3, and you eliminate the column and row of that particular element, and 1 into 1 1, and 1 into 1 1, that is 1 minus 1 plus what? You can eliminate the column and row of this element also. What you will get then? You will get 1 into 4, 4, minus 1 into 2, 2. This is equal to 0. Then alpha into 2 minus 4, that is minus 2, minus 0, plus 4 into 2, that is equal to 0. And minus 2 alpha plus 8 is equal to 0. 8 is equal to plus 2 alpha. Alpha is equal to 4. That is your answer. You can find in this way also. That's why actually you can find the answer with the property, but you don't want to learn that because it is deleted portion or it is rationalized. So shall we move to the next one? Is there any confusion with these questions? Okay. Next one. Show that the determinant is independent of theta. It is independent of theta. That means if you find the determinant, the theta will be not there. Only x or some other constants will be there. The theta is completely eliminate when you find the determinant of this particular matrix, or when you find the determinant of this. I'm going to find the determinant. It's an easy one. You only need to find the determinant and you want to know some trigonometry. That's all. That's all. I'm expanding this determinant with respect to the first column. I'm expanding this determinant with respect to the first column. Then what you will get? The first element is x, right? X. And I'm eliminating this column and this row. Minus x into x become what? Minus x square minus 1 into 1 become what? 1. And the next one and the next one, minus of sine theta, minus of sine theta into what? I'm eliminating the column and row. Minus sine theta into x become minus sine theta into x minus cos theta into 1, that is cos theta. After that, plus what? Cos theta into, eliminating these two columns and rows, minus sine theta into 1 become what? Minus sine theta minus x into cos theta become minus x cos theta. That's all. I'm going to expand this determinant. That is, I'm going to open the bracket. This become minus x cube minus x, right? Then minus sine theta into minus sine theta into x, that is positive x sine square theta, x sine square theta. Minus sine theta into minus cos theta become what? Plus sine theta into cos theta, right? Then cos theta into minus sine theta become what? Cos theta into minus sine theta become minus sine theta cos theta. This minus and minus become positive, and positive cos theta into x cos theta become plus x cos square theta. Here you can see these two terms will be cancelled off. Then what left is, listen. You can take x from these two terms. What you will get? The sine square theta will be there plus cos square theta will be there. Sine square theta plus cos square theta is equal to 1. So here you can say minus x cube minus x plus x into 1. This is positive x, this is negative x, and the final answer is minus x cube. That's all, guys. I think you get it. Shall we move to the next one? Ready? Here it's a case study question. It's an easy one. We don't want to find the more about this question. We only need to find Ax is equal to B and convert this particular question in the form of Ax plus X is equal to B and find determinant of A and find A inverse. Okay, we can do that. Listen, Gautam buys 5 pens, 3 bags and 1 instrument. Ready? I'm going to write X is the price of pen and Y is the price of bag and Z is the price of box. Did you get it? Then listen guys. Here Gautam buys 5 pens and he should pay 5x amount plus he buys 3 bag 3y plus he buys 1 instrument Z. All these amount together pays a sum of 160. Gautam pays 160. Ready? Then what about Vikram? Vikram buys 2 pens, so 2x amount, the amount will be 2x and 1 bag, that is y, and 3 instrument box 3z. all together he pays 190. What about the third person? He buys 1 pen, 2 bags and 4 instrument box. All these together he pays 250. Did you get it? So this is the equation. Convert the given above situation into a metric equation of the form X is equal to B. Here you can see A is the coefficients of this equation. 5, 3, 1, 2, 1, 3, 1, 2, 4. That are the coefficients. 5. I'm going to write the A is equal to 5, 3, 1. You can use these also. 5, 3, 1 and 2, 1, 3, 2, 1, 3. Also this one 1, 2, 4, 1, 2, 4. So this is A. What about X? X means X is a column matrix. That is the price of the things X, Y, Z. The variable that we don't know. Okay. Then what about B? B is a sum of the price of these things. That is 160, 190 and 250. So now we can write A X. What is X? X is X, Y, Z. Is equal to B. What is B? B is 160, 190, 250. These are B. Ready? Now the first question is over. Ready? What's the next question? Find determinant of A. What is determinant of A? That is 5, 3, 1, 2, 1, 3, 1, 2, 4. We want to find the determinant. I think you know how to find the determinant. Here 5 times 4 minus 6 minus 3 times 8 minus 3 plus 1 times 4 minus 1. Then what you will get? 5 times minus 2 minus 3 times 5 plus 1 times 3. Right? Then it's minus 10 minus 15 plus 3 minus 25 plus 3 minus 22 is the final answer. Did you get it? Then they also ask for A inverse. Can I rub this board? We only need this. X is equal to B is our equation. X equal to B. Ready? I'm going to rub this side. Okay. Then this is our determinant of A, and you can see we want to find A inverse. To find A inverse, we have to find the adjoint of A first. So to find adjoint, you want to find minor a first. What is minor a? Minor a, this is our a. What is minor a? Eliminating the column and row of the first element, you will get 4 minus 6, that is minus 2 and 5 and 3. After that, you will get 9 minus 1, that is 8. Sorry, that is 12 minus 2, that is 10. And 20 minus 1, 19. And 10 minus 3, 7. And 9 minus 1, 8. And 15 minus 2, 13. And last one, 5 minus 6, that is minus 1. This is minus, this is minor. And what about cofactor? Cofactor A, 1 minute guys. Then cofactor A, this is minus 2, this is become minus 5, this is become plus 3, this is become minus 10, 19, minus 7, 8, minus 13, and minus 1. I think you remember that is plus minus plus minus plus minus plus minus plus. You have to multiply the corresponding elements with the corresponding sign. Okay, did you get it? Okay, then this is our cofactor. And what about adjoint? Adjoint A is equal to what? Adjoint A is equal to minus 2 minus 5 3. We find the cofactor of, sorry, we find the transpose of the cofactor, then you will get adjoint A. Minus 10 minus 90, sorry, it's 19, minus 7, 8, minus 13, minus 1. After that, you can divide this adjoint A with the determinant of A. A inverse will be what? A inverse will be adjoint A by determinant A. That's all. You can divide each term with what? Minus 22. What you will get then? A inverse will be like what? A inverse will be like minus 1 by 11 minus 5 by 11 4 by 11. Sorry, it will be positive because it is minus 22. Okay, then it is minus 4 by 11 and 5 by 22 and minus 19 by 22 and 13 by 22 and 3 by minus 3 by 22 and 7 by 22 and the last one 1 by 22. This is A inverse. That's all. That's all. Okay guys, ready? If you multiply this A inverse with this matrix, you will get the value for x, y, z. Okay, if they ask for x and y and z, the price of pen, bag and instrument box, if they ask for that, you can multiply this A inverse because this is A, right? When it goes to the right side, what happens? It is A inverse into that particular set B, that is x is equal to A inverse B. X is equal to A inverse B. So if you multiply this A inverse with B, you will get what? You will get what? The x, y and z. It will be a column matrix. Okay, right? Shall we move to the next question? Is there any doubts? All good? Okay, I'm moving to the next question because the next chapter is a little bit need to be explained, that is probability. So it's a simple chapter actually. Matrices and determinants are very simple chapter, so we can move to the next question. Okay, the last question actually, the last question. Wait a minute guys. The last question. Using, sorry, this is not integration, using determinants. Determinant, find the area of the region bounded by the triangle whose vertices are this. If they give you the vertices of a triangle, then if they ask to find the area of that particular triangle, if they given the vertices of the triangle, you can use this equation. The area will be equal to half of the determinant 2 minus 2 4 5 6 2 and you can put the third element as 1. And sometimes you will get negative value for this particular determinant. You only need to take the magnitude of that. Otherwise, you can put mode for this whole thing. I'm going to find the answer. Half. You can take the first one within the mode, because I'm doing all this within the mode, because whether it is positive or negative, I only need the positive value. So if you take 2, what you will get? The row and column will be eliminated. Then what you will get? 5 minus 2 minus 2. I think 5 minus 2 and minus the second term is minus 2, and rows and columns are eliminated. 4 minus 6 and plus 1 times 8 minus 30. That is your final answer. Half mod 2 into 3 plus 2, 4 minus 6, that is minus 2, plus 8 minus 30, that is minus 22. Within the mode, a will be equal to half. This becomes 6 minus 4 minus 22. That's the final answer. That will be equal to half. 6 minus 4 will be like minus 2 minus 22. That will be like half mod minus 24. It will be like minus, it will be like the last one will be, the answer will be like 24 by 2, that is 12. Okay, that's all the answer, and this is the final question. We have covered all the topics in these chapters: symmetric, skew symmetric, transpose, and the properties of transpose, and the properties of determinant, like small properties, not the detailed properties, like determinant of a if you take if you take a constant outside the determinant, you should check how many rows is there, that kind of things. And that's all the chapter, these chapters. It's very easy to learn this chapter because it's simple, right? So that's all. The next session will be handled by our super teacher Fairuza, the chapter probability. He will be here in 2 minutes. Okay, bye, see you guys.
Welcome back, guys. I hope that you people are well boosted with the content of matrices and determinants handled by Master Fairul Rahman. So, I would like to utilize this opportunity to boost some portions from the content probability, one of the important chapter which I got the highest mark weightage, around 6 to 8 marks from the for the annual board examination. Okay, fine. Here we go. But before getting to that, can I ask you something? Tell me what are the points you are learning from this chapter. People, we're having 5 important topics, which includes number 1, conditional probability. Number 2, multiplication theorem on probability. Number 3, independent events. Number 4, Bayes theorem and total theorem on probability. And finally, the last one, random variable and the probability distribution. So you must need to know the exact concept what these topic are highlighting, and also you must learn to how to apply the concept which you learn for dealing with the questions. Okay, let us see. Question number 1, a question from conditional probability. So what is the question? You are supposed to evaluate what is the value of P of A union B. P of A union B is the thing that is being asked here. If it is given that 2 times P of A is equal to 5 by 13 and P of B is equal to 5 by 13, and also the value of P of A bar B is given as 2 by 5. People, tell me what is the formula you learned for P of A bar B. See, P of E bar F, probability of event E provided that F had occurred earlier. P of E bar F, the probability of event E based on the condition that F had occurred earlier, is defined as N of E intersection F, N of E intersection F divided by N of the denominator part, that is F. If you're dividing with both with some space, you can also modify the same expression as P of E intersection F divided by P of F, of which this definition are the most commonly used expression for conditional probability. So here in this question, it is given that P of A bar B, P of A bar B is equal to what? 2 by 5. People, tell me what is P of A bar B? It is P of A intersection, sorry, not union, A intersection B divided by P of B is given as 2 by 5, of which the value of P of B is given as 5 by 13. Therefore, I can say that P of A intersection B is equal to P of B times 2 by 5. P of B times 2 by 5. Now, if you substitute the value of P of B 5 by 13 over here, this will become 5 by 13 into 2 by 5. Whose value was found to be equal to 2 by 13. Gentlemen, you got what is the value of P of A intersection B. But remember, the question is not to find what is P of A intersection B. After finding P of A intersection B and after knowing what is P of A and P of B, you can find what P of A intersection B based on the formula that, P of A union B, based on the formula that P of A union B is equal to, what is that? P of A plus P of B minus P of A intersection B. The commonly used most important formula for the entire chapter probability in the 11th as well as in 12th. So here, union will become P of A. People, tell me what is P of A. It was found that 2 times P of A is equal to 5 by 13, which means P of A is equal to, take the 2 over here, this will become 5 by 2 into 13, that is 26. So if you substitute that value of P of A over here, this will become 5 by 26 plus P of B will be 5 by 13 minus P of A intersection B, which was obtained as 2 by 13. People, tell me how to simplify this. If you focus on these two terms, 13 is the common denominator. So 5 minus 2 by 13 will be 3 by 13. Now, we'll be having 5 by 26 plus 3 by 13. Now, if you multiply this with 2, you can say that this will become 26, this will become 6. So that you can make the common denominator of 26. So 6 plus 5, 11. 11 by 26 is the answer. The most important thing which you have to remember while dealing with conditional probability is that never expect a question dealing with the numerical stuff based on the formula, after learning P of A bar B is equal to, substitute these values and tell me what is the concerned element. Obviously, there will be some tricky elements like this. Maybe if this is given, you are supposed to find P of A intersection, and based on that, you are supposed to find the value of P of A union B. So please remember all the connection of these dot points. Okay? Fine, people. Can I go for the next question? Okay. See, before getting to that, let me tell you one thing. This is the numerical based questions. Now you can also expect the theory based questions from conditional probability. Okay, let us see a question of that kind. Question number 2. An instructor has a question bank consisting of 300 easy true or false questions. See, this is very, very important, guys. 300 easy true or false question. Let me write this for you. 300 easy true or false question. Now, 200 difficult true or false question. I'm having 200 difficult true or false question. So, altogether, how many true or false question? It can be either easy or difficult. Altogether, I'm having 500 true or false question. Now, next one. 500 easy MCQs. Sorry, multiple choice question. 500 easy multiple choice question, MCQ. And the next one, 400 difficult MCQs. 400 difficult MCQs. So altogether, I'm having how many MCQs? Together, I'm having 900 MCQs, which are either easy or difficult. So people, in this question bank, how many questions are there in the entire question bank? See, there are altogether 500 true or false question and 900 MCQs. So altogether 500 plus 900, there will be 1400 questions altogether. Leave it. This is a picture. Now what is the question here? If a question is selected at random from the question bank, then what is the probability that it will be an easy question, given that it is a multiple choice question? People, this is what they are asking here. Remember, while dealing with any question related with conditional probability, here you are supposed to find P of E bar F. So the obvious thing is that define E and F, so that you can find P of E bar F. People, what is the meaning of P of E bar F? It is the probability of event E. You are finding actually probability of event E. But one condition is there. What is the condition here? Event F had occurred earlier. So based on that condition, you are asking that what is the probability of event E. So based on that condition, that's why they are known as conditional probability. Okay. Now, what is E and F? That's the question. Remember, in every question of this kind, there will be two events. What are they? One will be, what is the probability that it will be an easy question? So this is one event. Selecting an easy question. Given that it is a MCQ, so selecting an MCQ is a second thing. In every events, in every question related with conditional probability, there will be two people, of which the first thing which you are supposed to find the probability, or what is the probability, should be event E. Now, the thing that happened in the past, which is represented by given that, it was observed that, it was found that, the event mentioned by using that phrase can be called as event F, so that it happened in the past. So understanding event E and F from the question is the most important thing. So obviously you can see two events in the question directly. But how to determine which one is E, which one is F? Remember, the thing that happens in the past, which is mentioned by, it is given that, it was observed that, it was found that, that thing should be event F. Now, the thing they are asking, what is the probability of an event? That should be what? Event E. So that you can find P of E bar F, probability of event E, provided that F had occurred earlier. Probability of event of selection of easy question, provided that F had occurred earlier, that is an MCQ is already being selected. It is given that an MCQ is selected. Now tell me, what is the formula you learn for finding P of A bar F? You learn an expression based on this. There are two expressions. Tell me what are they? Either this one or this one. Since in this question we are dealing with a number of questions, MCQs, true or false question, you can use this one. Okay. Now, what is that? This is equal to N of E intersection F divided by N of F. Number of event F. Selection of MCQ question. People, tell me what are the number of elements favorable to this event F. How many MCQs are there? They are not mentioning easy or difficult. I need the total count of MCQ. What is that? 900. So the denominator part will be 900. Now, what is the numerator thing? N of E intersection F. Tell me what is the meaning of E intersection of event E and event F. Both of them are to be satisfied. So here E is what? Selection of easy question. Event F is MCQ question. If both of them has to be satisfied, then it should be easy MCQ. Tell me what is the number of easy MCQ over here? This is equal to 500. So that the answer will be 5 by 9. As simple it is. Done. Alright. Even though this question seems to be much difficult, I will say that this is one of the most easiest section, I will say. You must need to know what exactly is happening here. Once you get to know what exactly happening here, you will say that probability is the easiest chapter in the entire 12th curriculum. Fine? Any doubts, people? So remember how to define event E and F if a question from conditional probability is being asked. By the way, how could you determine that this question is from a conditional probability after learning multiplication theorem, after learning Bayes theorem, total theorem, all those stuff? If a question is being asked, how could you say that? How could you distinguish that? Or how could you realize that this question is from conditional probability? There should be the term given that, observed that, found that, something that happens in the past. Conditional probability, event F. Got the point? Clear? Alright. Fine, guys. Next question. After knowing what do you mean by the conditional probability, the next thing is that multiplication theorem on probability. What is that? People, always remember that the concept of multiplication theorem, MT on P, multiplication theorem on probability states that P of A intersection B is equal to P of A into P of B bar A. This is the formula what suggested by multiplication theorem on probability. Now what exactly is this guy saying? This guy is saying that if I'm having two events A and B, the probability of selection of two things is equal to first one, probability of selection of first guy, into if A is over, now go for the next one, B. Provided that A had occurred earlier. If the event A had occurred earlier, then what is the probability of the second guy, event B? This is known as the multiplication theorem on probability. And remember, whenever you see any questions that is related with one after another without replacement. I repeat, one after another without replacement. One after another without replacement. One after another is sometimes also represented by in succession, in succession, in succession. Gentlemen, whenever you see any question which contains this term, one after another or in succession without replacement, remember that multiplication theorem on probability is the concept that comes to play. Clear, Dana? Let me show you how it works. Three cards are drawn successively without replacement from a pack of 52 well shuffled cards. What is the probability that the first two cards are kings? So, if I am having three cards, selection of three cards, people, see, if I am having three cards, they are asking that find the probability that the first two cards are kings. So first one is king, K1. Second is K2, second king. And the third card is an ace card. Now, how I came to know that this question is a question where I need to apply the concept of multiplication theorem on probability, because in the question is well mentioned that here I am drawing 3 cards without replacement from a pack. Without replacement. People, what do you mean by this stuff? Without replacement. If you select one card, we are not replacing it back. You throw it away. And you are going for the selection of second card. You select it and after again throw it away. And you go for selection of next card. Now, what is the difference of with replacement and without replacement? Imagine a scenario where I'm having a bucket of balls. If I select first ball and throw it away, and go for selection of second ball. Remember, the total number of balls inside the bag changes and hence the probability changes. So if the first event happens, the selection and throwing of the ball happens, then what happened? The probability changes. That is the significance of this logic. Okay, and one more thing you have to remember while dealing with this question is that here 3 cards are the selection. So there are 3 events. Now, what you will learn is that this is a multiplication theorem on probability for 2 events A and B. Now, my question is that what happens if I'm having 3 events A, B, C? Then empty on P states that P of A intersection B intersection C is equal to. Remember this thing. First one, second one, third one. First one, second one. Same thing. So first one, P of A. Now what happened? A happened. Now go for the next one. P of second one. Provided that the first thing happened, P of B bar A. Now after happening A and B, go for the next one, third one. That is P of C. Provided that both event A as well as B happened. That is A intersection B do happen. This is a multiplication theorem on probability for 3 events. Got the logic? If you remember this thing, you can define 3 events here. Event A, event B, event C. So people, how I came to know that there exists 3 events here? Because 3 cards are the number of cards that are taking from the back, from the packet of cards. If I'm selecting 2 cards, it should be what? 2 events. If I'm selecting 5 balls, there should be 5 events. Got the point? Now, what is A, B, C? Look into this. A represents the selection of first king. Let me call this as K1, first king. Now, B represents selection of K2, second king. Now, what is C? C represents the selection of the third card, which is an ace card. Now, once you know that here, multiplication theorem on probability is a question which you have to apply, go for the statement P of A intersection B intersection C is equal to P of A into P of B bar A into P of C bar A intersection B. People, just apply this concept based on the logic which you know. Number 1, P of A. What is the probability of selection of king 1, first king? By the way, how many kings are there in the deck of 52 cards? How many kings? Remember, in a deck of well-shuffled packet of deck of cards, remember, there are 4 sets, 4 suit. What are they? Heart, diamond, spade, and club. Now, each set contains how many? 13. Now, each of the 13 contains king, queen, jack, which are known as the face cards. 10, 9, 8, 7, 6, 5, 4, 3, 2, called as the numbered cards, and 1 ace card. Together, combining, constituting, or accounting the 13 set of cards in 1 suit. So, 1 suit contains how many face card? K, Q, J, 3. How many numbered card? 9, and 1 ace card. Remember, if this is a picture in one set, tell me what is the number of face cards in the deck of 52 cards which contains 4 set, which will be 4 into 3, which will be 12. Okay, so how many kings will be there? There will be 1 king in 1 set. So 4 set will be king, 4 kings. So what is the probability of selection of first king? King number 1 will be 4 by 52. Now tell me what is the probability of event B provided that A happened. What do you mean A happened? I selected first king and I am not replacing it. I am throwing it away. In that case, what is the probability of selection of second kings? I am going to select the second king. People, out of the 52 cards, if I take 1 card and throw it away, the card numbers left will be 51. And in that case, what is the selection of next king? Only 4 kings are there, of which 1 is thrown away. So how many kings will be there? 3. 3 by 51. Done. Into P of C. What is the probability of selection of ace card if A and B happened earlier, which means the first king and the second king is selected and thrown away. In that case, tell me what is the probability of event C? What is the probability of selection of third ace? People, how many ace cards are there? 1 ace card from one set, therefore 4 set, it will be 4. Therefore, the answer will be 4 by, but how many cards left? 4 by 15. Plus similarities. There are certain parameters which you have to remember. Number 1, without replacement, once you see in the question, remember this is a question of multiplication theorem probability. Now, if 3 cards are selected, define 3 events based on what they are supposed to get. Now, if it is multiplication theorem of probability, write the equation, write the answer, done. You can score 3 marks. Okay, Dane. Any doubts, people, you can ask. Okay? I know that you are cooking something for your board examination. Damn sure. Trust the process. Even your minute action for having the dedicated mindset for learning will be accounted for your answer sheet. Okay, trust the process. Just matter of 2 to 3 days. I know that you people are working a lot, you people are stressed a lot. I know that, guys, but trust the process. Things will be more better after 2 to 3 days. Okay, stay confident. Move in the next question. One more question based on multiplication theorem on probability. But before getting to that, you people must need to tell me how I came to know that this is a question from multiplication theorem on probability. See, a box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. Once I see without replacement, I'm damn sure multiplication theorem on probability is a concept which I need to apply. Now, if all the 3 oranges are good, the box is approved for sale. Otherwise, what do you mean by otherwise? Out of the 3, at least one of the guy is defective, was found to be not good, then it will be rejected. This is not, that box will not be approved for sale. Now, what is the question here? There is a person who manufactures oranges, but that box containing how many? 15 oranges, out of which 12 are good and 3 are bad ones will be approved for sale. Find the probability that a box containing 15 oranges, out of which 12 are good and 3 are bad ones will be approved for sale. So this is a common logical thinking, people. You know that for approve, you just imagine the picture, what exactly is happening here. You know that if you're running a food company, obviously people like food inspectors, the invigilators will be coming and they will be randomly selecting some boxes and they will be checking whether it is okay or not. You know, if there are a number of oranges, number of apples, they will never go for looking each and every apple. They will randomly select some of them. Here in this case, one inspector will be selecting randomly 3 of the oranges, and if they found that all the 3 are good, then what? It is approved for sale. That is the rule. Now, here in this context, they are speaking about a box which contains dash dash. How many dash? There are altogether 15 oranges, of which 12 are good and 3 are bad. The question is that what is the probability that this box is approved for sale? People tell me, in order to approve a box for sale, all the 3 selected oranges are supposed to be good, right? Because if all the 3 oranges are good, then the box is approved for sale. It is a mandatory condition. Okay, so how many oranges you are selecting? 3. Therefore, I am supposed to define 3 events. What are they? Event A, event B, event C. Now, what you are selecting? You are selecting 3 oranges. And for approving the sale, all 3 has to be good. So, selection of good orange number 1. Selection of second good orange, G2. Selection of third good oranges should be your 3 events. Okay? Event A is the selection of, good orange. Not God orange, it's good orange. Good orange number 1, selection of good orange number 2, selection of good orange number 3. Now people, once you know that this is a case of P of A intersection B intersection C, what is the answer? P of A into P of B bar A into P of C bar A intersection B. Gentlemen, tell me what is the value of P of A? P of A means what is the probability of selection of good orange number 1? See, out of these 15 oranges, 12 are good. Therefore, the probability will be 12 by 15. Now, what is the probability of event B? What is the probability of selection of second good orange, provided that the first good orange has been taken out and thrown it away? So, if the first orange is being taken away, in the box, how many oranges will be left? 40. Only 40 will be left, of which 11 are good. So, what is the probability of selection of second 11? 11 by 14. Okay. Now, similarly, what is next case? What is the probability of selection of third good orange, provided that first, second good oranges are taken away? So, people, how many oranges will be left here? If you throw 2 of them out, there will be 13, of which 2 of them are good. So, how many good oranges left? 10. Therefore, the answer will be 10 by 13. 10. Go the answer, people. Clear? Guys, any doubts here? Please respond. Is everything okay? This is how you can score for multiplication theorem on probability, one of the easiest portion. Tell me what is the thing that has which makes complication here. There is nothing to be complicated. See, if you see a question where you are seeing something like one after another without replacement, damn sure multiplication theorem comes to play. Number 1. Now you have to define 3 events or 4 events or 2 events based on the number of selection. Once you got write the equation of multiplication theorem, apply it. You got the answer, 3 marks, 2.5 marks. As easy it is. Okay, Dane? Going for the next question. Events A and B are defined such that P of A is 1 by 2, P of B is equal to 7 by 12, and P of not A or not B is equal to 1 by 4. The question is that state whether A and B are independent or not. People, here they are getting to the third topic, that is independency of events. Gentlemen, please tell me what you learned. The condition for independency. I will define this within 2 seconds. Sorry, 2 minutes. Independent events, as the title indicates, they are the events, they are not depending each other, they are independent of each other, which means that occurrence of one event does not affect the occurrence of the other event. What is the meaning of that? Event A happens or not will not be affecting the occurrence of event B. That is a pure mathematical meaning of independent events. Now, how it is being affected to the formulas which you learned? People, tell me what is this? P of E, probability of event E. Now, what is probability of E bar F? What is the meaning of that? It is also the probability of event E itself. It is also the probability of event E itself. Same as this. But what is the peculiarity? Provided that F had occurred or not. It is given that F had occurred earlier. In that case, what is the probability of event D? Here, they are simply what is the probability of event D. They are not all talking about, they are not all discussing whether F had occurred or not. Now, please tell me what is the logic of independent events. They are not depending each other. Occurrence of F does not affect the occurrence of event E. So in that case, both of them will be the same. Gentlemen, this is the rule number 1 for independent events. P of E is equal to P of E bar F. P of F is equal to what? P of F bar E. We will never forget this. This is the first rule of independent events. P of F is equal to P of F bar E. P of E is equal to P of E bar F. Rule number 1. You can expect 1 mark MCQs of this kind. Now, if this is the modification that you can bring on conditional probability, then tell me what is the modification you bring on multiplication theorem on probability. People, you already learned what is multiplication theorem on probability, that P of E intersection F is equal to P of E into P of F bar E. But it was observed that P of F is same as what? P of F itself. Therefore, this will become P of E into P of F. Therefore, people, I can define the second condition of condition for independent events, that P of E intersection F is equal to P of E into P of F. So in question, they will be given you P of E, P of F, P of E intersection F. All you need to prove is that whether they satisfies the condition of this one. Okay? You can also expect one more condition. What is that? What happened to P of E union F? People, tell me what is the formula you will learn. P of A union B is equal to P of A, here it will be P of E, plus P of B, that will be P of F, minus, what is next term? What is next term? P of A intersection F. E intersection F, which was found to be P of E into P of F. Gentlemen, these are the three conditions which you have to remember while dealing with independency of events. What is the point? Number one, P of E is same as P of E bar F. Number two, P of E intersection F is equal to P of E into P of F. And third one, P of E union F is equal to P of E plus P of F minus P of E into P of F. These are the three expressions of the on the application of independent events. Now, once you get that logic, tell me what is the answer for this. State whether two events are independent or not, or they are dependent or not. Guys, tell me, what is the rule? It is given that P of A is equal to what? 1 by 2. P of B is equal to what? 7 by 12. Now, what is the third rule? They are saying that P of not A. What do you mean by not A? A dash, A complement. Or is usually represented by using the symbol union. Not B, that is B dash, is equal to 1 by 4. Instead, remember, instead of or, it will be and. In that case, you can call it as intersection. You can take intersection. If it is or, it has to be union. Remember, if it is or, you have to take union. If it is and, you have to take intersection. Now, people, you know the formula that P of A dash is equal to 1 minus P of A. Basic formula, right? If you go to something dash, you can make or re-express this as 1 minus P of A. But the problem with this expression is that there are two dashes. So how can you bring the two dashes into one dash? The De Moivre's theorem which you learn, what is that? A union B, the whole dash is equal to, you can split this A dash and B dash. But remember, the union will be converted into intersection. And similarly, if it is intersection, then the intersection will be converted into union, so that you can split the two complements over here. This is how the De Moivre's rule is being defined. So based on that logic, see, if this thing is equal to this thing, you can say conversely this guy will be equal to this one. Therefore, how could you make these complement as a common term? How it is possible? P of, make this as a common term. This is union, therefore intersection. The whole dash is equal to 1 by 4. So people, what is the advantage? You bring the two dashes into a single dash, so that you can use the formula P of something dash is equal to 1 minus P of that is something. Therefore, this will be 1 minus P of that is something. What is something here? A intersection B, which is equal to 1 by 4. So people, from this expression, you can conclude that P of A intersection B is equal to, people, what is the answer? P of A intersection will be, take this other side, 1 minus 1 by 4, which is equal to 3 by 4. P of A intersection B is equal to 3 by 4. Now tell me what you are trying to prove. Here you are trying to prove that the condition of independency. People, you learn 3 rules for independency. What are they? Number 1. Number 2, number 3. which one you can prove over here? Here you can use this rule. P of, A intersection B is equal to P of A into P of B. People, if you found these and these two terms of the expression are equal, then you can say that the two events are what? Independent. They does not depend on each other. On the other hand, if they are not equal, they are not independent. Hence, they are dependent. Let us see what is LHS and what is RHS. P of A intersection B, P of RHS is P of A into P of B. It is well defined in the question that P of A intersection B is equal to 3 by 4. And the other two guys, P of A, P of B will be 1 by 2 into 7 by 12, which is equal to 7 by 24. People, whether these two guys are the same? No. In that case, I can say that they are not equal. P of A intersection B is not equal to P of A into P of B, which means that they are not independent. It means that they are dependent. People, what we are learning is the condition for independency, not dependency. Got the point? All right. Next question. A bag contains 4 red, 4 black balls. Another bag contains 2 red, 6 black balls. One of the two bags is selected at random and one ball is drawn from the bag, which is found to be red. Find the probability that the ball drawn is from the first bag number 1. People, after learning what is the logic behind conditional probability, multiplication theorem on probability, independent events, the 12th curriculum of mathematics is trying to say something which is very, very important, known as the Bayes theorem and the total theorem on probability, the most important aspect which you can see. But I will say that that is the most interesting part of the core of probability, one of the most interesting part. Once you know what is exactly happening here, you will be, you are capable enough to answer all the questions from that you can expect from that area. Okay, let me show you how it works. People, listen. I'm having two bags, bag number 1 and bag number 2. I'm saying that bag number 1 contains 2 red balls and 6 black balls. Now, bag 2 contains bag 2 contains 2 red and 6 black. Sorry, here bag 1 contains how many? Bag 1 contains 4 red balls and 4 black balls. People, this is the picture. I'm having 2 bags. See, some person comes here. He doesn't know which is the bag he was selecting. He go for selection of any of the random bag. And after reaching the bag, he go for the selection of a random ball. If it was found to be red, then what is the probability that the drawn red ball was from bag number 2, from bag number 1? That is the question over here. Okay, so people, if you are focusing 100%, if you are giving 100% mindfulness over here, trust me, all the 3 questions which I am going to discuss after this are gonna be very easy. Okay, listen. In every question, there exists two selection. The first thing is that the selection of bags, bag number 1 or bag number 2. Now, after reaching one bag or after selecting one of the bag, you will be going for the second selection of the ball. Here, it was found to be a red ball. So you can expect the first question, what is the probability of selection of a red ball? This is the first question. Question number 1, probability of selection of red ball. Now, if it was found to be a red ball, what is the probability that the drawn red ball was from bag number 1? The drawn red ball was from bag number 1. This is the second question you can expect. Okay, let me picturize this with some more examples. You can expect 2 machines. Machine A, machine B. Machine A produces 16% of the total product. This guy produces 14% of the total product. Now, out of the 16% of the product, this much of them was found to be defective, and out of the 40% of total production, this one was found to be defective. So if a person comes and select a random product item which was found to be defective, then what is the probability that the defective item was manufactured by machine A or machine B? So the first thing is that what is the probability of selection of defective item? Question number 1. Now if it was found to be defective, what is the probability that the defective item was manufactured by machine A or machine B? That is the second part. So in every question, remember, there exists two parts, where in the first portion you have to apply which theorem? This is a case of direct probability, the case of direct probability, where you have to apply the total theorem on probability. Okay, now after finding it was a red ball, you can expect the question in the reverse method. After finding the red ball, what is the probability that the drawn red ball was from bag number 1? That is the reverse case. This thing is known as the reverse probability. I repeat, reverse probability, where you have to go for the theorem known as the Bayes theorem. Gentlemen, for any questions related with this stuff, there are two things. The first thing is that direct probability, where you are supposed to apply the total theorem on probability. The second thing is that the reverse probability, where you have to apply the Bayes theorem. So there exists two things, right? Fine. Now, how to find the answer for this question? People, please be 100% mindful over here. Listen. What is the question here? Or what they are selecting here? They are selecting a red ball. So the first thing is that event A, define the event, selection of a red ball. Now, the red ball was present in where? Bag number 1 as well as bag number 2. So that is the first selection. So define E1, E2, not event B coming after A. This has to be E1, E2. That is the first selection. Selection of bag number 1. E2 is known as selection of bag number 2. People, out of the two bags are there. What is selection of first bag? The probability P of E1 will be equal to 1 by 2. Now what is P of E2? This is equal to also 1 by 2. So my question is that, then tell me what is the probability of selection of red ball. Find the probability. Question number 1, where you are applying the direct probability, where you are applying the total theorem on probability that looks like here. What is the probability of selection of a red ball? P of A. Gentlemen, tell me what is the rule. Here you can see that red ball was a ball that is present in this bag and this bag. See, if this is the only bag given in this question, tell me what is selection of red ball. You tell me it will be 4 by 8. If this is the question, what is the answer? If this parameter is not given, only this part. What is the probability selection of red ball? 2 by 8. So in this thing, the peculiarity is that red ball is present in both bags. So you have to sell the first bag and tell me what is the contribution of red ball from bag number 1. Plus, after that, you have to go for selection of second bag and tell me what is the contribution of second red, which is explained by the total theorem on probability, which are defined as, people, listen, P of even selection of first bag into P of A bar even. If even happens, if the first bag is being selected, then tell me what is the probability of A, the selection of red ball. Now, after that, go for second bag, P of E2, probability of selection of second bag. If you select what is the second bag, then tell me what is the probability of selection of red ball. That is second one. People, the thing is very easy, right? It was found that P of E1 is 1 by 2, P of E2 is also 1 by 2. Now, what is P of A bar E1? If even happens, which means the first bag is being selected, in that case, tell me what is the probability of event A? What is the probability of selection of red ball? Guys, if I'm selecting the first bag is selected, only this guy is over here, then tell me what is the probability of selection of red ball? This will be 4 by 8. Now, what is the probability of red ball over here? This will become 2 by 8. Gentlemen, you got the answer. Question number 1. Probability of selection of red ball is done there. Okay? Now, after getting the probability of selection of red ball, you can expect a reverse algorithm. What is a reverse algorithm, guys? If it was found to be a red ball, tell me what is the probability that the drawn red ball was from bag number 2. P of bag number 1. If it is bag number 1, bag number 1. The drawn red ball was from bag number 1. See, if you look into this expression, this is a contribution of bag number 1 and this is a contribution of what? Bag number 2. So that you can sum up this or total this, the contribution of the entire bag. That's why this method is known as total theorem on probability. Now, out of the total thing, they will be asking what is the contribution of what? Bag number 1. See, out of the entire thing, what is the contribution of bag number 1? This thing. So, how we are representing the whole term? That is P of E1 into P of A bar E1 plus P of E2 into P of A bar E2. Sorry. P of A bar E2. After writing the entire term, right, tell me what is the contribution of bag number 1. What is that? This term. That is P of E1 into P of A bar E1. People, you got the definition for what? The Bayes theorem, which is equal to, I can substitute the values over here, 1 by 2 into 4 by 8 divided by the entire denominator, that is 1 by 2 into 4 by 8 plus 1 by 2 into 2 by 8. Got the point, guys? This is something very, very important. Please tell me what are things you have remembered while reading a question of this kind. The thing is that, number 1, there exists the first selection, bags, selection of bags. The second selection of balls inside the bag. So that the first question is that the direct one, direct probability, the minute thing, the thing that the deepest. What is selection of red ball? Now, if it was found to be red ball, go to the first level. Find the probability that it was from the bag number 1. That is second part, where you have to use this thing and this thing. The total theorem on probability and Bayes theorem. Well, this is well explained for you. Okay. Now, what is the first event? Event A is a thing which they are talking first. Now, that thing should be present on where? E1 and E2. What is the probability of selection of defective item? The defective item should be manufactured by machine A and machine B. Alright, let us see, guys, one more beautiful example. Yeah, a factory has 2 machines, machine A and machine B. Past record shows that machine A produced 16% of the items of the output and machine B produced 14% of the items. Further, 2% of items produced by machine A and 1% produced by machine B were found to be defective. All the items are put into one stockpile and then one item is chosen at random from this and is found to be defective. What is the probability that it was produced by machine B? Gentlemen, listen. First of all, picture the scenario here. Here, people, I'm having 2 machines. How many machines? 2 machines. First one is machine A, second one is machine B. Now, tell me what is the percentage of their production. See, machine A produced 16% of the entire thing. So, the contribution made by machine B, machine A is equal to 16% and the remaining 14% was produced by machine B. Now, it was found to be 2% of the items produced by machine A. Out of the 16, for the 16, 2% was found to be what? Defective. Which means remaining 98 are non-defective. And similarly, here, out of the 14% production of machine B, it was found that 1% was found to be defective. Then people, tell me what are the 2 questions you can expect here. The first classification, selection of batch, selection of machines, production of machines. The second thing is that, what the bag contains. The bag contains red board or black board. The machine produces defective items. Okay? So tell me, what is the contribution? What is the probability of selection of defective items? The first question is that what is the probability of selection of defective items? Now, if it was found to be a defective item, tell me what is the probability that it was produced by machine B. Machine B. That is the second thing. Gentlemen, in every question you can see the areas where you apply the total theorem and the base theorem. So here, tell me how to find it. Defective and machine B. People, first of all, define the two events and the main event. Event A is that the selection of red ball. Red ball happens to be the deepest. So here, what is the deepest defective item? So the first one is selection of defective item. Now, the defective item was produced by machine A and machine B. So the next is the two events, event E1, E2, that is defined as selection of an item produced by machine A, the first guy. Second one is machine, selection of an item produced by machine B. So that you can write what is P of E1, P of E2. People, what is the probability of selection of an item produced by machine A? 16% are produced by machine A, which means that if there are 100, 60 are produced by machine A, which means this will become what? 16 by 100, and the remaining will become 40 by 100. So people, tell me what is the formula you learned for defective item. This is equal to P of E1 into P of A bar E1 plus P of E2 into P of A bar E2. What is P of E1? P of E1 happens to be, was found to be 60 by 100. And this is why P of E2 was found to be 40 by 100. Now what is P of A bar E1? A bar E1, P of A bar E1. What do you mean P of A bar E1? If E1 happens, if you found an item produced by machine A, then tell me what is the probability that it was found to be defective. What is that? Defective item produced by machine A will be 2%, that is 2 by 100. And similarly, machine B, defective item will be 1 by 100. You got the answer. Now, this was a contribution from machine A and this was a contribution from machine B. So we are asking that what is the contribution made by machine B, which means write the entire term, and up in the numerator you have to write the contribution of machine B, that is P of E2 into P of A bar E2. And this will be P of E1 into P of A bar E1 plus P of E2 into P of A bar E2. Ladies and gentlemen, these are the core concepts which you have to remember while dealing with base theorem and total theorem of probability. Please try to segregate, try to isolate, try to conclude something from any question. People, every question have a story to tell. So while dealing with a question, just don't go for randomly studying the steps. Try to learn what we are exactly doing here. If you learn to know how to conclude the points out of that, you can go for searching application of the same point, the same steps for dealing with any other question. That is the logic. If you fail to conclude the points, you cannot apply if a question of the same kind is being asked. Got the point? Clear? Any doubts? Comment box. So people, these are things which you have to remember while dealing with probability. You learn the concept of what? Conditional probability, the concept of multiplication theorem, the concept of independent events, the concept of Bayes theorem, total theorem. So I request all of you to practice much more questions related with the same stuff. So if you have any doubts, please feel free to contact with me. We can provide the best comment box, we can provide the best suggestion box, we do have the best explanation, everything. Okay, and take care of your mental health, guys. Thank you, have a good day.